this is basically the sensor that I used. Its model number is MQ2 gas or smoke sensor. Well, there are a lot of to sense like smoke and other combustible gases like LPG, alcohol, propane, hydrogen, methane, carbon monoxide. Well, this is like a sensor module in which this dome-like structure is main sensing thing, and the others like resistor and loading resistor, different thing present. So you can make a lot of different projects with this sensor, like home quality, air monitoring system, gas checker, detecting system. You can also measure the concentration of any gas present in the air in terms of ppm, parts per million. So it's a quite useful sensor, though it is not very accurate, but still for like small purposes it is very useful. Well, as I told you earlier, this is the main sensing material, in which like this material is present, which is used to sense the gas. Like this material is made up of aluminium oxide based ceramic, and around it there's a coating of tin oxide. The main sensing material is tin oxide SnO2. There is a chromium coil which heats up, and when it heats up it attracts all the oxygen in the air with the negative donor electrons of the tin oxide. So there is no oxygen present around it, and like no very less conductivity present, or you can say there's like a little current passes through it, very high resistance. So this is like the simulation. When there is any combustible gas or smoke present, it takes away the oxygen atoms from the tin oxide coating, and the electrons start flowing in the tin oxides. So like the resistance increases and the conductivity increases, or you can say the current starts to flow in other way, and like there's a voltage divider network on the other side, so we get a voltage at its output. So this is like the main hardware module, how this looks like. It goes like 4 pins connections, one for VCC, another for ground, and like the sensor also got 2 different type of outputs, like digital output or analog output. So it depends upon the use or application, which type of output we require. So there's like a liberty here. We can get digital output or analog output, it depends. It's like when if we are using the analog output, so it gives the voltage between 0 to 5 volt, depends upon the concentration of the gas it detecting. Like you see in the simulation, when there's like a more concentration of gas, the voltage increases. In a clean air, the voltage is like close to the 0 volts. So this is like the back side of the module, in which like there is a sensitive adjustment, or you can say potentiometer, in which like there is a load resistor present. We can increase or decrease the value of resistance to like adjust our sensitivity according to our need. There is like a complete specifications of this MQ2 sensor, like it operates on the 5 volt operating voltage. It's like a low resistance, as I told you earlier, present like maximum of 20 kilo ohms, so we can adjust it through potentiometer. This low resistance basically adjust the sensitivity of the sensor. This like heating consumption, like this sensor consumes maximum up to 800 megawatt of heat. Sensing resistance, or you can say its range is from 10 kilo ohm to 60 kilo ohm. Concentration scope. This concentration scope is like the most important thing in all its features. Tell us like it can detect about 200 to 10,000 ppm of any concentration of gas. Its preheat time like 24 hours. It's required some heating before it can detect any gas. So like if you need a more accurate measurement, you have to like keep it on for 24 hours. So yeah, this is like the specification of this sensor. Well, this is the same sensor, but the thing that I want to show you is this graph. This is like its sensitivity versus the resistance ratio graph, like the most important thing for this sensor. We use this graph to like find the concentration of any gas in a clean air. On the x-axis it's like the concentration of different gases in terms of ppm, parts per million, and on the y-axis it's the resistance ratio. Y-axis it's like a resistance ratio in which Rs is the resistance of sensor in the presence of any gas, combustible gas or smoke, air, which is like very variable here, and R0 is the resistance of the sensor in the presence of a clean air, which is like calibrated once and then we keep it fixed. So yeah, I was saying like the R0 is like the resistance of the gas in terms of the clean air, which is like calibrated once and it is kept constant, and like Rs is then changing, like depends upon the concentration of different gas, it can change accordingly. So this is like resistance ratio, and this is this graph shows us that the sensor can detect from 200 ppm to maximum 10,000 ppm of a concentration of the gases. So this is like its range. Also, the most important thing that we see from this graph is that as the concentration of any gas increases, in the graph, or you can say the resistance ratio, or more specifically the internal resistance of the sensor decreases. So we can say the voltage increases, like the most important thing. We can use this graph to like find the concentration of any other gases, like the gases at present. So this is like, so it is the simulation of the gas sensor MQ2 sensor, in which this is the gas sensor module. There is like 3 pins, VCC, output and ground. Unfortunately there is only one digital output present for the simulation, but in reality there is like another output which is like analog output, but for the simulation purposes only 3 output are present. And this is like the test pin in which we give different digital logics, for 0 for like low input and 1 for like high input. Unfortunately we can't give analog input to this sensor because like it's not available, so we can only give like a digital input to this sensor. The BCC is like connected to power source and ground is connected to ground, and it's like output pin is connected to the digital input 9 pin of the Arduino board. And then we take 2 LED pins, one for green LED and the other is red LED. The negative of LEDs are connected to the ground and positive of both LEDs are connected through resistor to the digital inputs 6 and 7 pin of the Arduino board. And then there is also LED and LCD display. Also use a 16:2 LCD display. We can also use a serial monitor, but I use the LCD display. It's up to you, whatever you want to do. There it is, a simple simulation. Start the simulation. See, it's like a green LED and it's showing no gas detected, because like there is no smoke or like combustible gas present right now, because at this test pin there is like 0, so like no gas present, and the digital the green LED is glowing. Whenever I give the 1 input to its 10 pin, see the red LED is going now and showing that the gas is detected. So like it's a simple simulation we can do here. And when I give the 0, sorry, the system is quite slow. See, the green LED is showing again and saying no gas is detected. When I give the 1 to this test one, see, so it's like a simple simulation. We can use it at home or like the places where like So basically here's the code for that serialization. First of all, we declare the LCD we used. We have to declare its library. So here's like the library included, and then we initialize the pins we used on the Arduino to connect with the LCD. We initialize it here, and then we initialize other pins we use. Like gas is basically the output of our gas sensor to Arduino input, digitally input. We use the 9 in pin, and then the two LEDs we connected to the 7 and 6 pins of the Arduino. So we initialize those pins, and then in setup we basically initialize what purpose those pins are used for basically. So like the gas pin is used for input, which gives the input to Arduino. We can also use the red LED and green LED as output pin, but it's not like necessary. So LCD dot begin 16/2 is used to like begin start the LCD. In a loop section is the basic program we develop. Here the condition digital read gas pin is equal to high is basically whenever there is a gas detected. So there is a 5 volt. This condition basically read the gas pin, which is like output of our sensor. Whenever there is a gas, the sensor gives the output of 5 volt to the 9 digit pin of Arduino, which it reads, and if it is high, then it basically print on the LCD that gas is detected, and it writes. Digital write is the function, built-in function used to like manipulate with pins. So it basically gives the high signal to red input, and gives the low signal to the 6 pin, which is green LED. And if the digital read gas is low, basically if there is like no gas is present, then it can display on the LCD that no gas is detected, and gives like low signal to the 7th pin, which is like a red LED, and gives the high signal to 6th pin, which is like green LED. And then there is a delay of 0.5 seconds, and then LCD will be clear. So this is like the simple program to like digitally read the output of the sensor. Well, this code is basically the analog read. If you want to read the output in terms of analog, then this is the code. Unfortunately, I can't do the simulation of that because the sensor only has a digital input and digital output. So we need a hardware for that, which is not present at the moment. So this is basically the code in which like there's a 2 pins connected to the LEDs. We initialize the 7th and 6th pin for 2 LEDs, and then we declare the pins as output. Just like before we begin the serial monitor. We can also attach the LCD here, but in this we use the serial monitor. And then in the loop section we declare 2 variables of data type float. We use them after in the program sensor value. So basically here we use the built-in function analog read from the A0 pin. If like in a hardware we connected the analog output of the sensor to the A0 analog pin of the Arduino, and we are reading from that pin. So analog read is gonna read the values from the A0 depending upon the concentration of gas. If there is like more concentration of gas, the more will be the output, and then all the values from this read is gonna store in this variable sensor value. And then we use the sensor volt variable to convert those values into voltage. This is like the formula in which like 5 volt divided by 1023 multiplied by the sensor value that is reading from the A0 pin. So all the values of voltage that we are getting from the A0 pin is going to store in this sensor volt variable, and then we're gonna display some functions on the screen, like you can display anything. Here this is displaying sensor volt is equal to those voltage values we're getting. And then here's a condition, like we can set any voltage value as a threshold value. For example, like if the output increases that particular threshold value, then we can attach any condition to it, like this glow this LED, or like on the buzzer, like we can do anything. So here I'll attach the condition, like if the sensor voltage is greater than 300, then digital right LED like red LED high. Like if the voltage at the A0 pin is like greater than 300, depending upon the concentration of gas, then the red LED will be on, otherwise the green LED will be on. Then there is a delay of 1 second, so like this will go on the loop repeating itself. So unfortunately this code cannot be implemented on the Proteus because we do not have the following sensor for that. If we had the like hardware, we can show it, but unfortunately we can only display this digital input output, in which like when there's a one input to the sensor, there's like red LED will be on and the gas detected, and when there's like no gas is present, the green LED will be on and no gas is detected. So here is it, the simple simulation for MQ2 gas sensor. Thank you.